Hi, Kira. Welcome to class. We'll get started here in a few minutes. Yeah, Kira, go ahead and write your name up on the board. Natalie and Tyler, you too. Since this is the afternoon session of this lesson. And then right at 1:35, I'll go ahead and start. Yep, there will be. Yeah, I gave you guys whiteboard privileges, so go ahead and put your name up there. Tyler, you too. Just under the attendance, just put your first name up there. Welcome, Rebecca. Thank you, Tyler. Thank you, Natalie, for putting your names up there. Welcome, Zane. Welcome, Riley. So the other thing that writing the name up on the board does for me is it lets me know that you're here and that you're paying attention and you're ready to start working. So that's one of the reasons why I have you do that. Okay, so it's 1:35. Let's go ahead and get started. Let me turn the recording on. So welcome to Earth Science A. This afternoon's lesson is over topographic maps, and we're going to start working on our 1.05 lab. What we don't get done today in explanation of the lab, we will work on tomorrow after our short lesson in our morning live lesson. So let's go ahead and get started with our topographic maps. Let me find the page. So this is where we left off in our lesson this morning. Scientists use maps to show locations, elevation, and surface features on the Earth. And topographic maps specifically show surface features. Elevation is shown on topographic maps, and elevation is the height of an object above sea level. Natural features such as rivers, hills, constructed features such as buildings and roads can also be seen on a topographic map. And topographic maps are made by using both aerial photographs and survey points collected in the field. So like what we were talking about in our lesson this morning, those surveyors, they take the overhead pictures with the airplane or the satellites, and then they also survey with specialized cameras to get those points of reference. Sea level, so up here it says it starts at sea level. So sea level is measured from the main sea level midpoint between the highest and the lowest tide levels in the ocean. So they look at the different tides over a period of time, and then they measure the highest and the lowest tide, and then they take the midpoint of that, and then on a topographic map, that is the mean or the middle. Yes, I am. Yep. So that is the mean or the middle. So when we start working on our topographic map, that 0 means at sea level, and our lab specifically has one spot in there where we talk about that sea level. Our maps will also have contour lines that we create. And on a topographic map, it provides more detailed information than like an aerial view drawing. And so we want to be able to show size, shape, and elevations. And in order to do that, we have some special symbols that we can use to help the person that's looking at the map determine certain information. The first one is the contour line. So the contour line is the elevation. So the elevation on a topographic map, and we show that through the contour lines. So if you look on the picture on the right, we see these lines here, the lighter ones. Those are contour lines. And in a topographic map, it shows elevation. Now the lines that we saw on the meteorologist map looked similar, but they didn't signify the same thing. These signify elevation on a landform. So if you look at this picture right here, you can see these lines. In between those main dark lines are the contour lines. The darker line that you see here is called the index contour line. And that is a reference point that is a major reference point, because you wouldn't be able to write 200 on every single line. It would get in the way. The difference in elevation between the contour line and the next is called the contour interval. So in between these index lines, so say we go from here to here, there's 100 feet. But that midpoint right there would be 150 feet. So the interval is 50 feet. How much do you think would be between the little lines on this map? $50? Maybe, well, if this big line here is 150, then between here and here is 50. So maybe 10 feet per line, or 150, maybe a little bit more than that. But index lines give us the major reference points. So like here is 100 feet, here is 200 feet, and this one is 300 feet. So every fifth line is usually bolded and is called the index contour. And an example would be 50 meters or 5 meters. Usually they go by 5s or 10s just to make it easier to multiply. The separation between the lines is based on an interval, and the cartographer is the one who chooses that interval. And it's usually based on the scale of the map and the relief. So the relief is the distance in elevation between the highest and the lowest points of the area being mapped. So say you start at sea level and you have to go up, we'll say sea level here, and you have to go up to, 7,000 feet. I mean, that's a huge jump. So you wouldn't do 5 meters. You'd have to do something more like 1,000 meters, right? To show a change in elevation that was rapid. So the cartographer decides that based on the difference between the lowest elevation and the highest. Okay, in lesson 1.5, there's an optional activity for the maps. There's 3 science notebook interactive activities that you can do. This is from one of those. So this is actually the answer key to one of those, and I wanted to make sure and give it to you. I wanted to show you that there are specific landforms that are shown on a topographic map. So things like plateaus and mountains, mountain systems, plains. So all of these different types of landforms can be shown on a topographic map. Okay, we looked at that picture of the island and it looks similar to this. So, but we were looking at it from the side and also from the top. But this is a top view of this picture to the right, a portion of it. And we can see that at the top we have the hill. And it's in a circle. And the interesting thing about topographic maps is the closer the lines are together, that means that it's really steep. So if you look at the picture on the bottom right, you can see those cliffs there. And the elevation is, the quick rise in elevation is signified by how close the lines are together. So we see like 100 feet is, really goes up fast and then it starts slowing down. We see a more moderate rise in elevation. From the side view, if you look at this side, we see an elevation going up. And when you look on the other side, this is an aerial point of view of this hill, of Baker Hill. So we are going to look at, we're going to create an island using our potato today, and we're going to look at it from the side like this and from the top. And we're going to create a topographic map from that potato. So this is a really good image to show you kind of what we're going to do, what we're going to draw, and I'm going to go through those steps with you today. But I want to go over some of the other things that you might find on a map, a topographic map. So V's indicate a valley. So if you see a V like this one right here, that's a valley. That's a valley. If a stream or a river flows through the valley, the V will point upstream always. So like this one, in the upper right-hand corner, this is downstream, this is upstream. Downstream, upstream. Contour lines that form a closed loop indicate the top of a hill. So that right there. And we saw that in the last slide right here. Top of the hill. I always thought this next one was really cool. This is the contour depression. So if you think about a volcano, you know how it has a depression in the top? That's signified by these lines. So they go perpendicular to the contour line, and that indicates that there's a depression there. Let's see. Okay, so let's practice for a couple minutes. What is the contour interval for the following maps? Let's start with number 1. What is our contour interval for number 1? Go ahead and put it in chat. So this question right here. So we have 100 and 700 to 800, yep. So between here and here, how many, we'll say this is feet. So how many feet is it? So there's 1, 2, 3, 4 lines in between. So we can 20. That's right. So the overall first interval between the index lines is 100 feet. We'll say 100 feet. And then between the contour lines is 20 feet. Okay, how about the one on, how about number 2? $10. 5 feet. Yep, it's 5 feet. And notice that there's no index lines in this particular picture. It only gives us feet. So, okay. So let's take a look at these contour maps, and we want to match them with their correct profile. So we're going to be looking at our topographic map and creating that profile map as well. So let's go ahead and match these. You can use your pen tool just to draw a line from each one. Very good. Excellent. Excellent job. Let me get my little pen tool out. Thank you, you guys did a great job. So those are matched correctly. Another thing that's shown on a topographic map is the direction of water. And those V's are valleys. So remember we have those valleys. And then the water always flows perpendicular to the contour line. Rivers flow downhill through the concave part of the contour. So if you go towards the V, the direction that the V is going is the direction that the water is upstream. So this is upstream. Then as it opens up, you can kind of think about it as a floodgate. So as you open the floodgate, the water goes out. You can kind of think of the V's that way. Okay, so take a look at this map. Which direction does the river flow? Go ahead and use your arrow. So which direction is downstream in that particular picture? Go ahead and use your pen tool to draw an arrow. Yeah, that's right. It's going down that direction. Well, kind of that direction. Let me get a different color. So it's more like this direction. So it's flowing that direction. And you can see the river in the middle, right here. Okay. Okay, so let's go ahead and start the lab. I'm going to give you guys a website that is a live link. There is a little bit of a delay. So I'm going to show you things and there's going to be a delay. So you just have to be patient. So the first things that you're going to need, well, go ahead and click on that link and then give me a green check mark once you have it open. You'll see like a ruler and a paper plate and a knife and some other items. I put the link in chat, so you should be able to click on it and open it. It's also on the board, so you could click on that and open it. It's still loading. Okay. It's a live YouTube video. So like I said, there will be a delay. Make sure that you mute the YouTube video because it's delayed, you'll hear me twice. So just have it muted. Don't mute our Blackboard session. Okay, it looks like Most everyone has it open, or it's loading for you. Okay, so for those of you who have it open, what you're seeing on there is, because I didn't have a lab kit, I don't know what's in your lab kit for this particular lab, so I went out and purchased the items that were listed on the materials list. So I purchased a ruler, some red food coloring. I purchased the 2 pens, you know, the black marker. And I got a potato, which I put in the water so it wouldn't go brown. Let me get it. I'll put the potato up there. Okay. So I'm going to move that, and then I'm going to put this on there. See if we can get it to show up. Okay, so because of the delay, it's going to take a minute for it to load and show you what the dish that I used and marked up. So we're going to go, let me cover this first. So this lab uses a potato to simulate the feature of an island landform. And we're going to make a topographic map to record the features of that landform that we create. Then we're going to read and interpret the information recorded on our map. So we're going to do all 3 of those things in this lab. What we don't get done today, we will work on tomorrow. Okay, so here's the potato island off to the right. So imagine that you live high on a mountaintop overlooking a lake. Your view includes a small island in the lake that is shaped oddly enough like a potato you might see on your dinner plate. During the hard rains of fall, Potato Island often disappears below the surface of the water. You decide to make a topographic map of the island to show others how the island really looks, even when it can't be seen. In this lab, you will use your potato to simulate that landform. Okay, so our first steps that we need to do are to take our container and create markings on it. I'm going to take a picture of what's on the board too, so you can see. It'll take a second to load. Okay, so in this container, you will take your ruler and you're going to mark out in centimeters, starting on the left-hand side, 0 to, whatever, however far you get, depending on the size of your container. And this is in centimeters, so I ended up with 11 centimeters on this particular Tupperware thing. Then on the, and you're going to put north on that side. Then on the east side, which is the left side, let me point here, draw an arrow. So this side right here, that's going to be the east side. And you're going to mark that east side in a vertical fashion. Hold on, let me take a picture. Again, you know, you'll be able to see this on the video or on the YouTube thing because it's live, but it is a little bit delayed. So you can look at it in the video or on our Blackboard. Oh, it looks like Natalie's system was not happy. Okay, so you're going to want to start with 0 down here and then do your lines moving up. So this is vertical. And this really is the elevation. So you want it to look like mine on the right, where you number it 0 to whatever. And you'll also put the E there. Now I put sea level just to remind me that that is sea level, 0. So let me, okay, so how many of you have your supplies with you? Go ahead and give me a green check mark. A couple of you have it. I just bought it at the grocery store. Okay, Jasmine, that's fine. You can just do this, just watch. Okay, for those of you who have your materials, I'm going to give you a minute or 2 minutes. I'll put the timer up, 2 minutes to label. Where's my timer? The rest of you, what I would like you to do is go into the lesson 1.05 lab and find the student guide. While they're labeling, you can find the student guide. Once you're done labeling, please give me a green check mark. Sarah, do you have a container and the markers so that you can at least get started? Okay, so go ahead and get started with it, and at least you can get it set up. Absolutely, Kara. Okay, so we have one person has theirs marked. Yes, this will be a recording. I'm recording it right now. Okay, so next, if you don't get done, that's fine. With labeling, you can go back and finish it here in a few minutes. So the next step in this process is to cut up our potato. And that should be showing up about right now in your, on the YouTube video, and I'll also take a snip of it. So there's 2 cuts that we're gonna put on our potato. 3 actually. So you're gonna cut the potato in half. So we're gonna do 3 cuts. Let me get my little, oh, why is that not working? Okay, so 3 cuts. Yeah, Blackboard's not being friendly to me. Cut number 1 is in half. You're gonna cut the potato in half. Number 2, you're going to cut the top piece. So I think you can probably see, like right here, I've cut out a flat piece. So cut out the top. And then number 3 is to carve out on the side. Okay, so just moving the potato around on the YouTube video so you can see kind of what it looks like. Okay, so once you've done that, the next part is taking the potato and putting it inside your container. And I'll show this on the video. Well, I'll just show the line. And then you're going to draw a line, and this is just going to help you keep the potato in the right spot as you're working with it. So what I had to do was I turned the container upside down. Yeah, it's the bottom of it. And I put the potato, I held the potato and put the container on top of it. Does that make sense? So I can write on the bottom of it. So I held it with my left hand because I'm right-handed, and then I did just a general circle around it. So if you have an odd-shaped potato, you know, it'll help you keep the potato in the right spot on the bottom. Okay. Let me get the paper plate out of the way. So when you look at it, you'll look at it from the side and you'll be able to see the numbers. If you look on the east side, you'll see the elevation, and the elevation for mine is about 6. It's hard to tell. There, it's about 6. The number 6 at the greatest part of it. Okay, so then the next step is you're going to take your lid And I couldn't find just a flat lid, but the lid that I did find was like, it was blue. So let me go back to the pages here so that you guys can see it. This is the student guide and how it's explaining it. So 1 centimeter is equal to 100 feet. So each one of those lines on the east side is 100 feet. So there's what we've done so far. Here's some other visuals of it. So you're going to dig out the top, dig out the side, and cut it in half. That's what your potato will look like. And you'll hold it and draw that line. You can kind of see a faint line down at the bottom. Make sure that you have each side labeled. So on the front where you wrote the ones going across the bottom, that's north. The left-hand side of that is east. That's where you put the vertical numbers. The right-hand side is west, and on the back side is south. So back here is south. So you'll want to make sure and mark those as well. Then what we're going to do is, this one you have to put your lid on and you kind of have to stand over it to look at it. And you're going to take your marker, not your Sharpie, but your dry erase marker, and you're going to put your lid on it. You're going to look, I'm not going to do this under here, but you're going to look at it and just kind of freehand the outline of it. And just do your best. If you mess up, cool thing about the dry erase marker is it comes right off. So I messed up on mine, so I'm going to redo it. You can even take your potato out and put it on the top to do your first initial one, if that's easier for you. So you'll just draw around, let me put this in the video, you'll just draw around the potato to get your first initial. Drawing, if I can get it to work, because it's kind of wet. Like that. Let me just fill this in. Okay. Then, once you have that first initial thing drawn, put the potato back in there. You're going to take the lid off and you're going to pour a little bit of water into the container. So let me pour a little bit of water in there. Then you're going to take your red food coloring and you're going to put some drops of the red food coloring into the water. And this will help you see I just put enough in there that it allows you to get kind of like a better view of what's covered. Let me see the knife. I'll put a picture up on there in just a second. Let me take a picture. If I can get my mouse to work. Okay, so let me put this up on the screen. And you're going to see something that's kind of interesting here. Kiera, is there a box in the lab kit? There might be a box, I don't know. This is just, I'm doing it without having a lab kit. Oh, I just got dye all over my desk. If you're using food coloring, make sure you have stuff down to protect your desk, unlike Mrs. Horton. Okay, so in your lab kit, if you do have your lab kit, you actually get a clear box with a lid. So that's nice. So it'll look probably more like what's in the lab instructions. This is just for students, the way I did it. If you don't have a lab kit, you can actually go ahead and do the lab this way. Okay, so if you notice here, do you see how the part of the island is covered up now with the water? That's going to change the overall topographic view of the water line. So I poured in enough water to go up to 100 feet. So on the elevation side, on the east side, I poured enough in there to go up to the number 1. So you want to pour enough in for each line, and you're going to do that on each line until the potato is completely covered. And in between filling it up with water and food coloring, you're going to draw that. So I'm going to put my lid back on top of my potato, and I'm going to draw what I see. I gotta bring this back here. Okay. Let me take a new photo. And it really does work better if you stand up over it. Like I'm sitting down and it's not necessarily the best measure. Okay. So we'll let that load up. Okay, so do you see the inner circle that I drew here on the right hand side? Notice my lid is colored. Your lab kit lid is not colored, so it'll make it that much easier. But this is the topographic map that we're drawing. And it's hard to tell because but anyway, so that at each level, I'm going to draw a line until the potato is completely covered. And what you're going to end up seeing eventually is where this dip is, you're going to see the inner thing like this. So it's going to be covered. So then you do your lines because that's a dip. And then you have at the top, you'll have this, and maybe here you'll have one. So it'll end up being like that. So that is the topographic side of it. So let's go back to this side. So you're just going to repeat for every vertical centimeter in your container. You're going to add water up to the next line and take a line. So basically that's every 100 feet. Okay, so the next thing that you're going to do is from these points, and in your lab document, you have something that looks like this. And tomorrow in class, I'm going to put this up on the board so you'll actually be able, you could like take a picture of your topographic map if you wanted to, and use room in our Class Connect to draw this if you wanted to plot it out. Or if you have the ability to take a picture, you can plot it out on your lab document. You can also plot it out on and scan your document in. So I just want everyone to know that I expect to see this and this. So this piece up here is actually where someone has traced their potato, and they've marked, if you notice here, they've marked 0, 1, 2, 3, and 4 centimeters. Their starting point at A and their starting point at B. And then at each interval on that line, they've plotted it down here on their plot. So like, let's do this. Let's see, they've done 2, so they did 1 here, they did 1 here. So we could do this one, and it goes up 100 feet. So it'd be like right there. This one is over here. So you just plot it on there to where it looks like this. So you're going to probably get, on mine, you would get something that looks like this. And that's a really rough drawing of my potato, but this is the profile of my potato right here, and this is the top view. So in your lab document, you'll need to have a picture of both of these. So the one on the top and the one on the bottom here. Question number 1, I think, is the top view, and then question number 2 is the profile view connected with the top view. And then there's a couple other questions. The lab itself is worth 35 points. So here's another example. So now that you're ready to create a profile of your map on your lab report, use your map and the blank profile scale on your lab report to make your profile. So in your lab report, there's actually a scale that you can use, or you can use the one that will be in the Class Connect for tomorrow. Note, if you still have your potato and want to get a sense of what your profile should look like, you can cut your potato island along the AB line. The side view of your sliced potato should look like the cross section. So you could actually cut this whole thing in half and it should be the same shape that you plotted. And that's how you double check your work. Okay. Okay, so that's pretty much the whole lab. Let me go back to the pictures that I took so you kind of have an image. The other thing that you can do that's kind of cool is that on the north side, you could actually draw what you see in your on the side. And then when you're cutting it in half, you're going from well, we're doing that. So you would go from north to south when you're cutting it in half, like that. So you want this part right here, you probably want it to be facing east when you set it up so that you can see that dip really well on your profile. That's how they did it in this one. So I believe this is probably east, this is west, this is north, this is south. So A would be north. Okay, are there any questions about the lab and how to complete it? Oh, this part right here, Riley, what do you mean? Is that on the bottom? This part here? Oh, I just mean like when you're setting it up, this part right here, when you're setting this up, I actually probably should have turned it so that the opening that I cut out on top, actually you can see it from the east side. So that was an error that I did. How do you turn it in? Excellent question. Okay, let me bring up let me go ahead and close the my broadcast, my live